Okay, next question that we got on the menu today. What is the derivative of cosine of x? So to format this as more of like a mathematically looking question, we have basically um, d over dx of cos of x. Um, Now this is kind of one of those things that you're gonna need to memorize, because it's pretty time consuming to like actually go through this as a proof. But just know that it is negative sine of x. Do not forget the negative. Never forget. If you forget it, well, you're going to be in trouble. But let's also think about this because the cool thing about sine and cos is that you can keep on taking the derivative over and over again, and you're going to start to see a pattern. So let's take the double derivative, d of dx, oops, of d of dx of cos x. This is just equal to the derivative of sine x, of negative sine x rather. I know the derivative of sine x is cos x. Well, this is just negative cos x. Take the derivative of negative cos x, we get positive sine x. Take the derivative of positive sine x, we get cos x. And wow, we're back where we started. So that's a nice thing about the derivatives of cos and sine. They follow the pattern. Just make sure that you keep those negative signs in line, because otherwise it will be uncomfortable for sure. So the above solution that we got here, it says the derivative of cosine of x is negative sine of x, so we can mark that as correct. The above solution is correct. Clean off the whiteboard and send that in, and we can get it. Move into the next question on the menu. So what is the quotient rule for differentiation? The quotient rule for differentiation is very important when you are taking the derivative of a function divided by another function. So in this example, we have f of x and g of x. It gives us the general form, but I'll run us through an example just so that we can see how this general form works when it's in action. So the general form of the quotient rule, f of x over g of x, those could be any functions: trigonomic functions, polynomials, exponentials, logarithms, any function that's valid. So this is equal to the derivative of the top multiplied by the bottom, just regularly, minus the regular top times the derivative of the bottom, all of that divided by the bottom, but you got to square the bottom. If you don't square, I will care, and it does impact the calculation a lot if you have the bottom there or not. Okay, so let's run this through an example. Let's say we have d over dx. Let's say we have something like e to the x, and then we have x plus 1. So let's see how the quotient rule works in action with this. So we know that f of x equal to e of x, f prime of x, the first derivative, well, e of x, it's super simple. It is just e of x. Nice and simple. G of x, we have x plus 1. G prime of x is 1. Just simply 1. So to sub these into our equation, we have the derivative of the top, so e of x. Multiply that with the natural version of the bottom, so that's x plus 1, minus the natural version of the top, also e to the power of x. Multiply that with the derivative of the bottom, so that's just 1. All of that divided by the bottom squared. So that's x plus 1 squared. On the top, how about we factor out the e to the power of x? These two terms both have e to the power of x. We can factor that out. To the power of x, and what's left is x plus 1, and then the minus 1. And then on the bottom we still have x plus 1 squared. And in here, the plus 1 and the minus 1 zero each other out, so that will be e to the x times x over x plus 1 squared. Sometimes it's more reasonable to leave not to like expand that out, but yeah, that would be your answer for the derivative of this function. Looks good, feels good, sounds good, is good. So yeah, the solution that we have here is valid and accurate. Above solution is correct. Cool. So let's clean up the whiteboard and mark the solution as correct. Oh, I guess that was the last question. Time flies when you're having fun, as the old saying goes. Let me just switch my camera real fast. So that concludes all the questions that I'm going to cover today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and ring that notification bell below. And if you'd like to submit your own questions, please visit the video links or the links in the video description below. And remember to leave a like and a comment if you like the video, and share the video with your friends if you find that this was helpful or you think that this might be helpful for your friends. This has been Millen from OneClass, and I hope to see you soon. Bye now. Have a good night, and have an amazing day as well.